Okay, to start the baseline assessment review for geometry, I have to write an algebraic expression, 8 less than m. Now, I'm first going to state two very common mistakes before I write down the answer. I've seen students write this, and I've seen students write this. Okay, now it says an algebraic expression. This is an inequality, so that won't do. Now, why doesn't 8 minus m work? All right, so 8 less than m. It means you're taking m, and if you want 8 less than m, that means you have to subtract 8 from it. Okay, so that's your correct answer. Now, 3 minus 4 is different than 4 minus 3. All right, the order in which you subtract quantities matters. All right, so you want to be very careful when you're working with the operation of subtraction. All right, for number 2, we're just plugging in the values into the expression. -9 times -3 plus a, which is -4, times b minus c. All right, so we have 27 plus -4 times 8 minus 2, which is 6. 27 plus -24. So I have 27 minus 24, which is 3. Done. Simplify. -2 to the 6th power. So it's -2 times -2 times -2 times -2 times -2 times -2. All right, multiply these, I get 4. Multiply these, I get 4. Multiply these, I get 4. Then I have 4 times 4, which is 16. And then I have to do 16 times 4, which is 64. All right, very easy to do. For the next one, I have 4 times the square root of 3, that whole quantity squared. So I have 4 square root of 3 times 4 square root of 3. All right, now I multiply the whole numbers, which gives me 16. I multiply the radicals, which gives me square root of 9, and the square root of 9 is 3. You could have just went straight to 3 by recognizing that you're multiplying radicals with the same value inside, so you just end up with that value inside. All right, however you want to do it. So I end up with 48. Here I have 2 over the square root of 10. How do you simplify this? Well, we don't want a radical in the denominator position. We want to get it out of there. So how do you get rid of a radical? Well, the easiest way is to multiply it by itself. So I end up with 2 square root of 10 over 10. All right, because square root of 10 times square root of 10 is square root of 100, which is 10. All right, now I can simplify this fraction here, which is 1/5. So I end up with 1 square root of 10 over 5. So that gives me square root of 10 over 5. All right, no radical in the denominator position. We're good then. Done. For 6, I'm going to multiply the whole numbers. I get 24. I multiply the radicals, and I get square root of 6. And there's nothing else we could do here. We're done. All right, so it's 2 times 3. That's where you get the 6 from. Just want to clarify that. All right, for number 7, just take your time working this problem out. The square root of 64 is 8. All right, then I have plus 10. And let's break down 12. All right. Now, we don't know the square root of 12, but we could simplify it. So we have 2 times 6, making a prime factor tree. I have a pair of 2's. So I end up with times 2 square root of 3. All right, square root of 3 is left inside. All right, and I have minus 5 times, going to do the same thing with 48. I got 2 times 24, 2 times 12, 2 times 6, and 2 times 3. I have a pair, I have another pair. So I'm multiplying 2 times 2. What's left inside the radical is 3. All right, so simplifying everything here, I end up with 16 plus 20 square root of 3 minus 20 square root of 3. All right, so then these just cancel out, and I'm left with 16. Done. All right, for this exponents problem, I have a power to a power, and in this case, I always multiply when I have a power to a power, so I have k to the 6, and I'm going to have times k to the 4. All right, now I'm multiplying exponents here. So what do you do with the powers? You add them. So end up with k to the 10th power. Done. For the next problem, I have 4/5 w x to the 5th, the whole quantity squared. Now, we have an exponent of 1 here for the 4, exponent of 1 for the 5, an exponent of 1 for the w. So then I just take this 2 and I multiply all of these exponents by the 2. So I have 4 to the second, 5 to the second, w to the second, x to the 10th. So I have 16 over 25, w squared, x to the 10th power. Done. Multiply. I have two binomials that I'm multiplying here. So I have to use a special process known as FOIL. So first, outer, inner, and last. All right, so I have 3z squared minus 34z minus 24. Done. All right, find the slope. All right, for this problem, we're going to use the slope formula, y1 minus y2 over x1 minus x2. You may have remembered it this way. All right, it doesn't matter which way you do it, just as long as the y's are on top and the x's are on bottom and you're consistent between the first point and the second point. All right, so I'm going to use y1 to start with. I have 9 minus y2, which is negative 6, over x1, which is negative 6, minus x2, which is negative 3. So I end up with 9 plus 6 over negative 6 plus 3, and I get 15 over negative 3, which is equal to negative 5. That's my slope. Done. All right, for 12, I need to isolate x. So the first thing I'll do is subtract 15. And I get 16 is less than or equal to negative 8x. I divide by negative 8. And I'm going to flip the sign because I'm dividing by a negative. All right, but I want the variable on the left side, so I switch everything to get the variable on the left side. And that's my final answer. For 13, first thing I have to do is combine like terms. All right, so I have negative 5 plus 5y. All right, now it's your choice how you want to shift things around now. I will subtract 5y, bring it over to the left side. So I have negative 10y plus 6 is less than or equal to negative 5. And I'll subtract 6. So I have negative 10y is less than or equal to negative 11. I divide by negative 10. And I get y is greater than or equal to 11 tenths. Alrighty? Done. For 14, I have a compound inequality here. So whatever I do to the left side, I also have to go over and do to the right side. So if I'm going to add 3 here, I have to add it to every component, left, middle, and right. So I have negative 2 is less than 2y, which is less than or equal to 26. Then I divide by 2. So I have negative 1 is less than y, which is less than or equal to 13. And that's all I could do. I'm done. For the next one, combining like terms, I have 4y, 18y, negative 10y. That's going to give me negative, oh no, it's just 12. 12y. Yep. Minus 19 is equal to 29. All right, now I'll add 19. That gives me 12y is equal to 48. If I divide by 12, Then I get y is equal to 4. Done. All right, for 16, the first thing we have to do is distribute. So I get 3w plus 6w plus 6 minus 10 is equal to 11w minus 12 plus 6w. Okay, now I need to add like terms. Okay, I'm almost there. 17w minus 12. Okay, now it's your choice how you want to shift things around. I'm going to just do this. Subtract 9w. So negative 4 is equal to 8w minus 12. Then I'll add 12. All right, so then I have 8 is equal to 8w. Divide by 8, and w is equal to 1. Done. All right, 17. I have a fraction in this equation. We don't like fractions. We want to get rid of them as fast as possible. So this is one way to do it. You just multiply by the denominator on both sides. All right, it cancels out on the left side. So I'm left with negative r minus 8 equals 28. All right, now the problem becomes very simple to do. Negative r equals 36. Divide by negative 1, and r is equal to negative 36. All right, for this equation, we need to multiply by a number that will get rid of all of the fractions. Let's look at all the denominators. The largest is 6. Do the other denominators go into 6? Yes, they do. All right, so then you just simply multiply by 6 on both sides. And how does this work exactly? All right, I take 6, I divide it by 1, and then I multiply it by 24. I get 144. I take 6, I divide it by 6, I get 1, times 1 gives me 1. So it's just n. Here I have 6, I divide it by 3, I get 2, times 1, which is 2. So here I'll subtract n. 144 equals n. Okay. Going on to the next problem. All right, here I have a fraction on both sides of the equation. And when you have one fraction on each side, to get rid of the fractions, you simply cross multiply. So 14n is equal to 3 times 5n minus 2. So 14n is equal to 15n minus 6. All right, here I'll subtract 15n. I got negative n is equal to negative 6. Here I'll divide by negative 1. N is equal to 6. That's all there is to it. Done. All right, for 20, I'm going to factor out the x, and then I'm left with x minus 9 equals 0. All right, if you're not sure if you're doing it right or not, just distribute, and you should end up back to where you started, and you know you factored correctly. Once I have the expression factored, then I set both parts equal to 0, and I solve for x. Alrighty. For 21, there are many different ways to solve this type of problem. I've seen many teachers use different methods. I'll be using the big X method. Okay. So this is how I approach this problem. I need to find two numbers that add up to negative 3, multiply to give me negative 10. All right, because I'm trying to factor this expression here. Those two numbers are 2 and negative 5. All right, so I end up with two binomials, m plus 2 and m minus 5 equals 0. Now if I FOIL this, it takes me back to where I started, so I know I did correctly. All right, so now I take both pieces and I set them equal to 0. Done. For the next one, these numbers are pretty big. Is there anything we could do to make this a little easier? We could factor 5 out, okay? Because 5 is a common divisor. So I factor out 5. Oops. And I have 4y, and I have minus 12. Okay. All right, so since this expression here is of the form ax squared plus bx plus c, I'm going to use the big X method just like I did in the previous example. So I have 5 here. I have negative 4 on top, negative 12. What two numbers add up to negative 4 or multiply to give you negative 12? It's going to be 2 and negative 6. So I have y plus 2 times y minus 6 equals 0. Now I set every part equal to 0. Now, does this mean anything? 5 equals 0? No, it tells you nothing about y. So make sure you don't write y equals 0. I've seen many students do that. Here I have y plus 2 equals 0. Then I have y minus 6 equals 0. All right, so we subtract 2. Y is equal to negative 2. Here I add 6. Y is equal to 6. Done. All right, for 23, there's no value that divides into all these numbers. Okay, so what do? I have ax squared plus bx plus c to work with in this problem, so I'm going to use the big X method. But there's one subtle difference from the previous two examples. The a value here does not equal 1, so you have to take that into account. My b is negative 11, but on the bottom I'm not just going to put c, I'm going to put a times c. So it's going to be negative 42 on the bottom. All right, now what two numbers add up to negative 11 and multiply to give you 42? Now think of multiples. 1 times 42, 2 times 21, 3 times 14. Okay, 3 and 14, that gets you 11. How? 3 minus 14. And yeah, those two numbers work. Cool. So now do not write this. This is a very common mistake. All right, I've seen a lot of students do that. Because this a value is not equal 1, you can't just factor it after getting these two values. Okay, so that does not work. Make sure you don't do that. What you're going to do is write the first term, take the second term, break it up using these two values. Plus 3p minus 14p, and then minus 7 equals 0. Okay, so this is a for sure method for always getting the right result. I've seen other methods being taught where it's sort of a trial and error, but with this one it takes you straight to the correct answer. So now I have 4 terms here. What factoring method can you use when working with 4 terms? The grouping method. All right. Out of the first group, I could factor out a 3 and a p, which leaves me with 2p plus 1. Out of the second group, I could factor out a negative 7, leaving me with 2p plus 1. Okay? And so I have 2 terms. I'm going to factor out a 2p plus 1, and then I'm left with 3p minus 7. Okay? Equals 0. Now I set both pieces equal to 0 and solve. All right, piece of cake at this point. Just take your time. Show all your work. Often students try to do everything in their head and they miss a negative or they multiply incorrectly. Just take your time to do it all step by step. All right, step by step is so important. All right, then you don't miss anything, or you're less likely to miss something. All right, so there are the values of p. Done. All right, for 24, I just need to isolate r squared. Subtract 48. End up with negative 48 is equal to negative 3r squared. Next thing I need to do is divide by negative 3. I get 16 equals r squared. Now how do you get rid of the square? You square root both sides. And when you introduce a square root into an equation, don't forget the positive and the negative. So I end up with positive negative 4 equals r, or r is equal to positive negative 4. All right, if you plug both of those values into the original equation, it works out to be true. Okay, here I have a system of equations problem. I have two equations with two unknowns. My unknowns are x and y. To solve a system of equations, you could use the elimination method or the substitution method. And there's many different ways to approach solving the problem using either method. First thing I want to do for elimination is get each equation to have this structure. Okay? And first thing I'm going to do is switch these terms. Now, I'm just reordering them, so I don't have to add or subtract or anything like that. Just reordering them. But here I'm going to add 14, so I bring it over to the right side. Okay? For the second equation, I have negative x, and here I'm just going to subtract 2, because I want to bring the constant over to the right side. And here I'll subtract 3y to bring it over to the left side. So I have minus 3y, and that's equal to negative 2. All right, so the x's are going to cancel out now, since I have everything lined up. And the whole goal is to get them to have the same coefficient with different signs, which is what I have here. So they cancel out. And now I add up 5 and negative 3, which gives me 2. And then I have 12. So then I end up with y equals 6. All right, you take the 6 and plug it in wherever you like. I'll plug it into the second equation from the original setup. So I have negative x plus 2 is equal to 3 times 6. And negative x plus 2 is equal to 18. Subtract 2. Negative x equals 16. Divide by negative 1. And x is equal to negative 16. All right, now my final answer is a point. It's negative 16 and 6. So if I graphed these two equations on a coordinate grid, they would intersect. There would be two lines. These are equations of lines. There would be two lines that intersect at this point. All right, that's all there is for the baseline assessment. If you understand all these concepts, you should do well on the baseline assessment exam. Let me know if you have any questions prior. And throughout the whole school year, make sure you're asking questions if you ever have any. Don't let those gaps build up. Then they begin to bite you down the road. And that's all.